Welcome to clickmyproject.com. Let me discuss about the project detection of life-threatening arrhythmias using feature selection and support vector machines. Let me discuss about the abstract of the project. Detection of ventricular fibrillation and rapid ventricular tachycardia is crucial for the success of defibrillation therapy. A novel detection algorithm that combines ECG parameters with SVM to identify VF or shockable arrhythmias has been presented. SVM learning algorithms can improve the efficiency for the detection of life-threatening arrhythmias. FS techniques might help to provide valuable insights to build highly accurate detection algorithms. Prompt detection of VT and VF episodes is crucial to deliver an electric shock therapy, and in this way increase the probability of survival from a SCA incident. The development of automated external defibrillators that analyze the surface electrocardiogram ECG signal if either rapid VT or VF is detected. Ventricular fibrillation versus ventricular tachycardia, making it difficult to assess the real performance. In this previous method have used genetic algorithm or discriminant analysis. The performance of the proposed SVM detection used and combined three different FS filter type techniques into a single ranking score, allowing us to determine the relevance of each ECG parameter using the score in the SVM classifier to yield a robust result. In this approach, Hurst index and the PSR parameter was calculated. Case of SVM classifier using unbalanced dataset which provide arrhythmia detection problems. Temporal or morphological parameters, spectral parameters and complexity parameters have been measured with the filter technique. The BER metric is an interesting magnitude to set the free parameters of the algorithm. Detection performance of the analyzed parameters. This procedure is an interesting method for evaluating the discrimination ability of a set of ECG parameters performed well. This SVM algorithms combining ECG features significantly improves the efficiency for the detection of life-threatening arrhythmias. FS method has been combined to the SVM algorithms to provide a robust classifier using a reduced set of ECG parameters. In future, we implement multicast SVM classifier with ADA boost by a SVM in a binary classifier, that is, a class labels can only take two values, either plus or minus 1. Binary tree architecture takes advantage of both the efficient computation of the tree architecture and the high classification accuracy of SVMs. Value can also be interpreted as a confidence value. Larger the value, the more confidence ones is that the point belong to the positive classes. Enhance the binary classification type of normal and abnormal. In multiple classification, the types divide into normal stage, moderate stage, beginning stage or severe stage. Let me discuss about the flow diagram for our process. First, the input signal generation is done. ECG signal need to be generated for processing and analyzing. Read input signal with the represented format. It showed as ECG waveform, mean subtraction, 5-order moving averaging filtering, high pass filtering, low pass Butterworth filtering is a typical pre-processing techniques, that is noise removal processing. In the pre-processing, input signal needed to be pre-processed before going to process the signal. Here there are many processes for pre-processing steps prescribed, that is mean subtraction, moving average filtering, high pass filtering and low pass Butterworth filtering. With these methods, noise, low quality signals and acetol will be removed. The Butterworth filter has a maximally flat response. The moving average is the most common filter in DSP, that is digital signal processing, mainly because it is easiest digital filter to understand and use. In spite of its simplicity, the moving average filter is optimal for a common task, reducing random noise while retaining a sharp step response. This makes it is the premier filter for time domain encoded signal. The moving average filter and its relatives are all about the same at reducing random noise while maintaining the sharp step response. Next, in the feature extraction algorithm, the feature after completion of noise removal process in ECG signal need to extract the feature parameters from the ECG signal. Temporal or morphological parameters can be extracted, where TCI, TCSC, STE, MEA and MAV parameters are extracted, which are the time domain representation. In spectral, parameters are estimated for frequency domain, where we flick M and A2 parameters and median frequency, and that is FM, are extracted. Complexity parameters are the different measures which comprised of complexity measurement, PSR, Hill and sample entropy. Finally, the SVM classifier are performed, where the input ECG signal features and also entire database features are parsed. In the classification process, support vector machine has been used, which is binary classifier. SVM maps input vectors to a higher dimensionality vector space, where an optimal hyperplane is constructed. Among the many hyperplane available, there is only one hyperplane that maximizes the distance between itself and the nearest data vectors of each category. This hyperplane, which maximizes the margin, is called the optimal separating hyperplane. The margin is defined as the sum of distances of the hyperplane to the closest training vectors of each category. SVM classifier have only one user chances of parameters, but the kernel is a very big rug under which sweep parameters. SVM belong to the general category of kernel methods. The kernel method is an algorithm that depends on the data only through dot products. Next, when in this case the dot product can be replaced by the kernel functions. SVM maps input vectors to a higher dimensional vector space, where an optimal hyperplane is constructed. Among many hyperplanes available, there is only one hyperplane that maximizes the distance between itself and the nearest data vectors of each category. Finally, the result obtained, which produces the ventricular fibrillation or non-ventricular fibrillation of ECG signal, whether shockable and non-shockable signal provided. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. This is the main window for our analysis the ECG signal using feature extraction and SVM. By pressing the input signal button, we can browse the input signal from the dataset folder. Here we can select any one signal from the dataset folder. Here I plot the ECG signal in the axis 1 plot. By pressing the pre-processing button, we perform the noise removal operation of our filter. This is the mean subtraction of our filtering result, and this is the moving average filter. And finally, we got the low pass Butterworth filter in the axis 2 plot. By pressing the morphological parameter, we perform the morphological feature values. Here we got the morphological feature values. By pressing the spectral parameters, we perform the spectral parameter values for our input signal. Here we got the spectral feature values. By pressing the complexity parameters, we calculated the complexity parameter values for our feature values. Now by pressing the classification button, we perform the classification operation. Finally, we got the graph and result. This is the non-ventricular fibrillation signal, and if the signal will be non-ventricular, then it will be non-shockable signal. And we got the performance measures of accuracy and sensitivity and specificity for our SVM classifier performance. And this is the ROC curve plot. And this is the analysis graph between accuracy for existing and proposed system. This is the analysis graph for sensitivity. This is the analysis graph for specificity. Finally, got the comparative analysis between the VF and shockable detection scenarios. VF classification problem. The SVM algorithm based approach or proposed FS system might help to better recognize the data. Thank you.